welcome back to Maths Chat. Today I'm going to be showing you how to graph straight lines on a Cartesian plane. This is so fundamental to many different topics, not just in linear relations, but topics to come, and potentially even previous topics that you may have covered in class. When graphing straight lines, it's really important that you use a ruler of some sort so that you can graph some awesome straight edges, and also maybe use pencil just in case you make a mistake along the way. So let's have a look at how to graph straight lines. The way that this first example is set up, if we look at the equation, I have y equals 2x minus 1. Now this format is what we call the Y-Intercept and gradient method. That is because when it's in this form, it is y equals mx plus c, where c is your y-intercept and m is your gradient. So y-intercept is obviously where it intersects the y-axis, so where it hits this line, and the gradient is the steepness or the slope of the graph. So a slope going like this is extremely steep, and a slope going like this is not so steep. If it's in this form, whatever is multiplied by the x is my gradient. So I have a gradient of 2. Now gradient, another way to remember it, is rise over run, where the rise is how much we go up and down, and the run is how far we go left and right. Using this, I also know that my y-intercept is going to be -1. And we can use both of these, both the gradient and the y-intercept, to help us really easily graph this line on my Cartesian plane. It's always good to start with the y-intercept. If it's at -1, this means that it's going through this point. And straight away, I'm going to label that as 0, -1, because I'm writing my x value for the coordinate first, followed by my y value. And because x is the horizontal line, this means that my x value at this point is 0. Now the best way to find my second point is to use the gradient. So if I've got my rise over run, this means that I've got 2 over 1. I've got 2 as my rise and 1 as my run. Now a lot of people get confused by why this is over 1. The reason is because every single number that's not a fraction is over an invisible 1. So in this case, the 2 is actually 2 over 1, which is why I can simply say that my rise over run is 2 over 1. Coming back to here, because I've already put in that y-intercept point, I'm now going to go to the right. We're not going to worry about whether it's positive or negative just yet. If you go to the right, you should get it right every time. Think right is right. So I'm going to go 1 to the right, because that's my run. Then at this point, my rise is 2. Now because there is no negative in front of there, we can assume that it's a positive, and because it's positive, I'm going to go up 2. So 1, 2. And my second coordinate that I'm going to write out is 1, 1, because I've already moved 1 across, which is my x value there, and 1 up, which is my y value. If this had been a -2, from this coordinate here, where I went 1 out, I would have then gone 2 down. Okay, but because it was positive, I went up. Since I've now got 2 points on the graph, I can just connect them. And I'm going to label this as y equals 2x minus 1. And that is how you graph this line. Now it's really important that you show at least 2 coordinates on your graph, as well as your y label and your x label on the top and the right hand side. The next example. Now you will notice that this is not set up like our first example was, which had y on a side by itself and the rest of my values on the right hand side. I now have x and y on the same side with just one value on the right hand side. A great way to solve this is what we call the x and y intercept method. What that involves is individually subbing in 0 first into x and then into y to solve for the corresponding value at that point. Now the reason that we can do that is because the way that the intercept works, at my y-intercept, doesn't matter where it is on this entire line, x is always 0. Just like how on my x-axis, my y value will always be 0 also. So we use that in helping us come up with what the graph looks like. So first of all, x-intercept. Remember that I said that at the x-intercept, y is always equal to 0. So we're going to solve for what x could be when y is equal to 0. That whole thing, that whole term there becomes 0. So I'm left with 3x is equal to 12. Divide both sides by 3. X is equal to 4. So therefore, I've got a point at 4, 0. And just like I did before, I'm going to label it straight away. Now let's find the y-intercept. If I've got 3, 0 plus 4y is equal to 12, so that becomes 0. Therefore my coordinate is 0, 3. And again, I'm going to put that in straight away. So 0, 3. Just like I did before, when I've now got those 2 points, I can connect them with a line. And that's done. Now technically, I can use both methods in both of these scenarios. So I could have used my x and y intercepts to solve for my intercepts here, and then use those as my coordinates. However, in this case, it's much easier to use the gradient and y-intercept method. In this example, I could have rearranged and then put it in this form where I had y by itself, something multiplied by x, and then a constant on its own. However, as you noticed, it was much easier to just sub in 0 for both x and y. So it really depends what your strengths are, as well as what you notice being the quickest or easiest way when you're working it out. Either way, you'll notice that I labeled 2 values, and I also neatly drew one solid line between them, which is really important when you're sketching graphs. If you have any questions on that, please make sure that you leave your questions in the comment section below so that I can help you out if you need it. Also, you may find it easier to go back to your either textbook or your maths teacher or tutor and ask them more about graphing straight lines. Please hit like on this video and subscribe to this channel so that you can be aware of any updates on Maths Chat. I'll see you next time. Bye!